Water makes up 60% of the human body, providing the medium for almost every internal biological process. Yet, despite this biological requirement, most people live in a state of mild chronic dehydration. We often treat drinking water as a reaction to thirst, rather than a constant requirement for baseline operations. Because this state is so frequent, we tend to accept afternoon fatigue, bouts of brain fog, and tension headaches as unavoidable parts of the day. These symptoms are not just random inconveniences. They are specific signals that the body's internal resources are running low. To understand why these signals occur, we need to look at what happens to your biology when water intake stops. By tracing the chronological breakdown of a thirsty system, we can see exactly how a lack of fluid compromises performance. The process begins at minute 0, the moment your water intake falls below what your body requires to maintain its current activity. Your brain detects this rising concentration of solutes in the blood and initiates a systemic coordination to prevent further loss. This diagram shows the pituitary gland responding to that detection by releasing antidiuretic hormones into the bloodstream. Once these hormones reach the kidneys, they signal the organ to conserve water, pulling it back into the system. This immediate conservation effort results in darker urine and a noticeable slowdown in renal function. This hormonal shift prioritizes the retention of fluids over the efficient flushing of cellular byproducts. While this response secures your short-term fluid levels, it marks the beginning of a broader decline in operational efficiency. After a few hours of low hydration, the effects move beyond hormones and begin to impact the physical properties of your blood. This cross-section of a blood vessel illustrates how total blood volume decreases as the body loses water, leaving the remaining blood thicker and more viscous. This change forces the heart to work harder to circulate this denser fluid, struggling to deliver oxygen to your brain and muscles. The resulting oxygen deficit leads to fatigue and tension headaches. To protect the heart and brain, the body begins to pull water from less critical areas, such as the skeletal joints. We can see here that the layer of synovial fluid meant to lubricate the joint is thinning out. As this lubrication decreases, friction across the cartilage rises, resulting in the physical stiffness and discomfort often felt during movement. The brain fog and physical tension we experience are the direct results of these mechanical struggles within the circulatory and skeletal systems. When we look past these daily symptoms, we can see the long-term impact of maintaining a dehydrated state for months or years. Chronic dehydration keeps the body in a cycle of constant internal friction and cardiovascular strain. This chart compares a healthy cell to one in a chronically dehydrated environment. The increased internal stress causes the dehydrated cell to degrade at an accelerated rate. Over a lifetime, this accelerated aging leads to a measurable decline in cognitive performance and brain health. These facts suggest that hydration is about much more than simply satisfying a temporary thirst. Consistent water intake is the primary mechanism for maintaining your internal environment and supporting long-term health. Maintaining these fluid levels is what allows your cellular machinery, energy levels, and vital organs to continue functioning as they should.